Hello, this is the section 7.4 activity lesson. This activity is on the topic of understanding confidence levels. Now this lesson is a very brief introduction to this activity. Once you finish the lesson, you're going to print off a worksheet. You're going to do the worksheet, and then you're going to do some homework on My Math Lab. So this activity deals with concepts from both sections 7.2 and 7.4. In 7.2, we talked about constructing confidence interval estimates of a population proportion P. And so one of the examples that we did in that section was this example of students using credit cards, where we surveyed 750 students. We found that 480 of them used credit cards, and so we calculated a sample proportion of 0.64. That sample proportion is what we call a point estimate of a population proportion P. And so we mentioned in 7.2 that whenever we estimate something, we want to get some measure of just how accurate that estimate is. And so we measured its accuracy by constructing a confidence, a margin of error E, and then using that margin of error, we constructed a confidence interval estimate of P. And so here was our final result. I won't go through all the details of how we did that. In the end, we let the calculator do all the work. But there was our confidence interval estimate of P. And so then we interpreted that confidence interval in this way. We said that we are 90% confident that our true value of P is somewhere between 0.611 and 0.669. And so the question that we want to try to answer in this activity is, what does this really mean? Specifically, what do we mean by 90% confident? Section 7.4, we dealt with similar calculations, except we dealt with means rather than proportions. So one example we did there was estimating the mean IQ score of all statistics professors, where we went out and surveyed 25 professors. We got a sample mean of 121 and a sample standard deviation of 5.9. So this sample mean of 121 was an estimate of our population mean. So we asked the question, well, just how close is that sample mean to the true population mean mu? So in other words, just how good of an estimate is it? And we answered that in the same way as in 7.2. We calculated a margin of error and then use that to calculate a confidence interval. And so here was the results. Again, I won't go through the details of the calculations because we let the calculator do most of the work. And so we interpreted that confidence interval by saying we are 90% confident that the mean IQ of all professors is somewhere between 119 and 123. Again, we want to try to answer the question, what does 90% confident really mean? In 7.4, we talked a little bit about what it does not mean. So a 90% confidence interval does not mean that the probability that mu is between 119 and 123 is 0.9. That 0.9 is not a probability when we think about just a single confidence interval. Now, why is it not a probability? Well, because mu, our population mean, is a number. It's either between 119 and 123 or it's not. There's no probability involved. It's either there or it's not. Now, we don't know which, but it's one or the other. We can say that for sure. So there's no probability involved. So what does a 90% confidence level mean? And we're going to try to answer that, illustrate it with our activity. So the first thing for this activity is you're going to print the section 7.4 activity worksheet. And it contains 3 pages. The very last page consists of a whole bunch of numbers looking something kind of like this. This is only a small portion of that list. But each one of these numbers represents the height of a woman. So our first woman here is 59.8 inches, our next is 63.6 inches, and so on and so forth. So there's a total of 1,008 women in this population. And we're going to try to answer some questions about these heights. So there are two things that are true about this population. The first is that exactly 45% of these women are taller than 64.0 inches. Now, how do I know that? Well, it's because I let the computer look through all 1,008 of these numbers. It counted the number of heights that were bigger than 64.0 inches, divided that by 1,008, and it came up with exactly 45%. So you just have to take my word for it. This number, 45%, is the exact value of our population proportion. One other thing that's true about these heights is that the mean is exactly 63.7. Now, how do I know that? Well, because I added up all 1,008 of these numbers, divided by 1,008, and we came up with exactly 63.7. Just take my word for it. So this number is the exact value of our population mean. Now, in this activity, we're going to pretend that we don't know this number or this number, and we're going to try to estimate them by taking random samples of women and using those random samples to construct confidence interval estimates of P and mu. So again, we're going to pretend that we don't know these two numbers, and we're going to try to estimate them. So on the first page of the activity, you're going to see a table that looks something kind of like this, except there's no numbers in there. So the very first thing that you're going to do is you're going to get 4 different samples of 15 women. So you're just going to randomly select 15 women and write those 15 numbers in this first column here. And then you're going to do that again. Get a different random sample of 15 women, and you can just randomly pick them. Just put the sheet out and randomly put your finger down, write down that number. Do that 15 times for the first sample, 15 times for the second sample, another for the third, another for the fourth. Okay. The next thing that you're going to do is count the number of heights that are bigger than 64.0 inches. So for instance, in this first sample, if I just look down at this number here is bigger than 64. This number here is bigger than 64. This number is bigger than 64. Now this number is not bigger than 64, so I'm not going to count it. This number here is bigger than 64, and this number here is bigger than 64. So I have a total of 5 heights that are bigger than 64.0 inches. The next thing I'm going to do is use that information to calculate a confidence interval estimate for my population proportion P. And we're going to go to the calculator. We're going to use the same calculator command that we did in section 7.2. That's option A, the 1 proportion Z interval. And the way my window is going to look when I enter this is X here is my number of successes. That's the number of heights that are bigger than 64.0 inches. And then N here is my sample size, which is 15. All of these samples are size 15. This number here is not my population size. This is my sample size 15. So this number is always going to be the same. And next we enter our confidence level. Now in this activity we're going to use an 80% confidence level. In most of the activity or most of the examples and homeworks we used either a 90, 95, or 99% confidence level. This one, to do something different, we're going to use an 80% level. So set that to 0.8, and then you hit calculate, and this is the result that I get. So this second line here is my confidence interval, and then I'm going to write that confidence interval here in this row. I'm just going to round things off to 2 decimal places. So you see 0.18 up to 0.49, and that's it for my confidence interval. Next thing I'm going to do is ask myself, does that confidence interval contain the true value of P, which is 0.45? Well, 0.45 is indeed between those two numbers, so I write yes. Now I'm going to do the same thing for sample 2. In this case, I had 8 heights bigger than 64 inches. I calculate my confidence interval in the same basic way. In this case, again, that confidence interval does contain the true value of 0.45. Now, we're going to do kind of the same thing, but we're going to calculate a confidence interval for mu. Okay? So we're going to use the exact same 4 samples of data, and we're going to use our option 8 t-interval command to calculate that confidence interval for mu. Now, the very first thing we're going to have to do is enter each one of our samples into a list. So go to your data edit menu, and I'm going to enter my sample 1 here in L1. You can do sample 2 in L2, sample 3 in L3, so on and so forth. I've entered just sample 1 right here. Okay? So then we're going to go to the option 8 t-interval command. I'm going to choose input data, choose list L1 because that's where my sample 1 data is, choose frequency of 1, and then a C level of 0.8. Again, we're going to use a confidence level of 80%. Now, we're going to use this input data here. In section 7.4, we used input stats, but we're going to use data here in this case because we have the raw data entered into our calculator. So again, set your C level to 0.8, hit calculate, and here's the results. This row here contains my confidence interval, and I'm going to write that confidence interval right here, 61.998 or 97. I guess I didn't round very good, up to 63.57. Okay. And then we're going to ask ourselves, does that confidence interval contain 63.7? Well, notice that 63.7 is bigger than this upper limit. So that interval does not contain the true value of 63.7. Doesn't mean we did anything wrong. Just means our confidence interval doesn't quite contain 63.7. Now we're going to do that same thing for sample 2, and here's my confidence interval, and notice that the interval does contain 63.7, just barely. This lower limit, 63.69, is just barely below 63.7. So 63.7 is indeed inside the interval, so I write a yes. Okay, so do that for all 4 of your samples. And so again, do that on the activity worksheet. On the second page of the worksheet, there's some questions to answer. And you're going to analyze the results and talk a little bit about what it means. And then you're going to do some homework on My Math Lab.